Hi, my name is Dewey, and today we're going to learn about something called volumes of revolutions. Okay, so what this is you want to find the volume of a 3D circular shape, and that includes a disc and a washer. Today, it's very easy to tell the difference between the two. Some people have trouble, and that's why we're going to go over it. And the first one we're going to go over is the disc method, and it comes with its own equation. So let's do an example of it first. So this method, here's the example. It's y equals 4 minus x squared and bounded by x0 and y equal to 0. And we're going to rotate that around the x-axis, or rotate about the x-axis. Okay, so what does that look like? Well, let's see. This is our y equals 4 minus x squared parabola, and we bounded by the x-axis, which is the red line right here, and the green line, which is y equals 0. So that's the y-axis. And we bounded it so it only gets that part, and we're gonna rotate around the x-axis, and we get something that looks like this. As you can see, it looks kind of like an umbrella, a hooded kind of thingy dome. And our objective for this is we have to find the area inside of this whole thing. And to do that, we're gonna need an equation, and we're gonna start it with the radius. Radius. Oh, I must spell that wrong. And the radius is y equals minus 4 minus x squared. This is our equation, integral from a to b, pi times f of x squared times dx. And the radius is going to go where f of x is. So rewrite that. Okay, so now we need to find our b and our a in this definite integral. We definitely have them. So let's look back at our 3D object here. Our a and b is going to be on lines on our x-axis because it's rotating around the x-axis. So our bounds are going to be on the x-axis, and the first one is going to start at 0, right? Because it's bounded by y equals 0. So obviously it's going to minimum value, our minimum bound is 0. Now maximum bound is going to be here, this location right there, where the graph touches is the x-axis. So this is our first, and this is going to be our second. And to find the second, it's not that hard. So let's take a look. So our a is going to be 0 because we're starting at 0 and the x line is 0. But what about our b? So if you recall, the graph touches the x-axis, meaning that the y is 0. So our maximum x value is on the x-axis, which means our y is 0. So we're going to set y equal to 0. And we're going to use the original equation and solve for x. So minus 4 on both sides, isolate the negative variable, and then square root it, and get plus or minus 2. And since on the positive side, we only want 2. So our b equals 2. So now let's rewrite the whole equation again. So we should have from 0 to 2, minimum maximum bounds, pi times 4 minus x squared dx. And we can isolate the pi on the outside, so pi times the integral of 0 to 2 times 4 minus x squared to the second power dx. And that's our equation. And to solve it, simply just do the integral and substitute in your bounds, and that's all you have to do. That's how you find your area. For now, we're just gonna set up the equation, and that's what we have as our answer. Alright, so let's do the exact same problem again, but this time I'm gonna try and rotate it around the y-axis instead of the x-axis. So we're gonna do the same problem. 4 minus x squared, x x-axis. And I'm going to show you what that looks right now. Alright, here's what it's going to look like. So as I rotated, so before I rotated around the x-axis, which just looks like this. But now I'm going to rotate on y-axis, and as you can see, oh, that's the z-axis, I'm so sorry. This is the y-axis, and you can see it's using a different radius now. It's using this radius instead of that radius. So it's using this radius on the x-axis, and it's also got new bounds. So since we're rotating around the y-axis, we're going to use the y bounds, which is going to be here, and it's going to be here. So this is going to be your minimum bounds for the rotation around the y-axis, and it's going to be your maximum bounds. So in order to solve this, we will need to set everything to in terms of y. So that means the radius, this right here, we need to be set in terms of y. So we have to solve for x instead. So if you solve for x, you should get square root of minus 1. I'm just skipping a step. You can do that. Isolate the x variable. Now you need to find your bounds. So, like I said before, your minimum bound is on x equals 0. Therefore, your minimum bound is going to be 0. Your maximum bound, however, you can solve for that. Because the maximum bound lies on the y-axis, your x is going to be 0. So, if your x is 0, your y is simply going to be 4. So your b is 4. Now that we have everything we need, we can simply rewrite the equation. Simply start your integral from 0 to 4, and you would put pi times your radius, which is square root of 4 minus x squared, and this is very important, it's now in terms of y, so you gotta put dy. Just remember, when you rotate around y, it becomes dy. Isolate the pi, and you have pi times the integral from 0 to 4 minus square root of 4 minus x squared in terms of dy, and that's how you set up the equation. Now we're going to move on to washers, and we're going to start off with a problem. It's a bit different, so we're going to start off with a problem here. Y equals 2x squared. We're bounded on the x equals 0, which is the y-axis, and we're bounded y equals 0, which is the x-axis. And we're going to also bound it on x equals 2. And rotate that about the y equals 4. So this is going to be a graph, and this part right here is going to be our 2x squared. This is where we're bounded by y equals 0, and this here is where we're bounded by x equals 2. The red line is going to represent y equals 4 in this case. So we're going to rotate it around the x-axis. Okay, and this is what it's going to look like. And we're going to have two radiuses that we need. Yeah, so in order to find the area, we need to find the whole area first and then minus this part. I'm going to show you to do that right now. Alright, this is the generic graph for it. You can see y equals 8. And to solve for this, we're going to do v volume equals the integral from a to b pi times capital R of x squared minus lowercase r of x squared. All of this turns dx. Now, what is our capital R of x? Well, usually when you have just a graph, when you first draw it out, you're going to draw two radiuses, and this is going to be our big one from 8 to 0. That's your big function, that's your bigger radius, bigger function to your axis, and your lowercase r of x is going to be from your top function to your lower function. So your bigger r is going to be 8, and your smaller r is going to be the top function, 8, minus the lower function, which is 2x squared. And now, we need to find our a and our b. And our a is obviously going to be 0, because since we're rotating our axis, we're using the x values, and the x value starts at 0, and the final x value is 2. So we put those all together to an integral from 0 to 2, pi times 8 squared, you see it has to be squared, minus 8 minus 2x squared, which is a lowercase r of x squared. In terms of dx, and that's how you solve, that's how you set up the equation. If you want to solve it, you just put it in a calculator and solve it, and that's it. That's all you do. Alright, now we're going to do some practice problems. And I'm going to set up two problems. I'm not going to tell you what method you're going to use with this or a washer. I'm just going to give you two problems and try to do them in your own. Pause the video, and I'll show you the answer afterwards. So first one we begin is y equals 2x squared, y equals 0, x equals 0, and x equals 2. We're going to rotate that. I'm going to rotate that about, let's see, I'm going to rotate it about the x equals 2. So the horizontal line on x equals 2. In the second problem, we're going to find the volume. So before we only found the integral, we only set up the equation, but now we're going to find the volume. Remember, you have to do the integral, and we're going to do this without calculators. So I'm going to find the volume. Sorry, I have terrible handwriting. Without calculator. Okay, and calc. And our problem is going to be y equals 2 square root of x minus 1, y equals x minus 1, and we're going to run on x equals 0, and y equals negative, oh no, x equals negative 1, y equals 0, that's what it was. So, try your best to solve it. Pause the video.
Got a fucking dog in your neck. You're crazy. You're crazy, man. You're crazy. I like you. You're crazy.